Now let's add the 5-number summary to this summary right here in terms of our description of the data. So from the spreadsheet, we calculated that earlier. We have our min for the data set, quartile 1, median, quartile 3, and the max. So if you don't have the spreadsheet in front of you, check out the description of the video. There'll be a link there. So let's just get a screenshot of this. We just need the summary. I've already played with the mean and standard deviation. Now it's on to the median and the other percentiles. All right, so what we want to do is use a number line, and the histogram already has a nice number line, so we can just go off that one right there. So for now, I think I'll pull out the z-score number line. So we're done with that for now. Let's add a new number line for the 5-number summary. And we'll just put it right here underneath. And we're going to use this scale up above when we mark these numbers. So the min is 1.6. So 1, 2, 1.5, just a little to the right of 1.5. So I think that'd probably be about right there. And then Q1, 5.8. 5, it's pretty close to 6, so maybe about here. Median, 7.25. So 7, 8, that's 7.5, 7.25, probably about there. 9.35, so about a little over a third of the way to 10, which I think is going to be about there. And then 15.5, so halfway in between, probably about there. So I've marked off the numbers on a nice linear scale. I always like to do it with the histogram for a comparison there. So then what we do is we make a box from Q1 to Q3. So that's the box of our box plot. And then the median, we use that to split the box there. So we can spread this out a little. We draw then, if it's not already there, a whisker out to the min and a whisker out to the max. So erase these extra parts here and here. And the line through the middle is no big deal, but we do need that whisker heading out that way. So this is a box and whisker plot, or what's known as a box plot, and it's based on these 5 percentiles. So the minimum, the 0th percentile, right, there's no numbers below that. Q3 lives right here. Let's label these. Min, this one right here is Q3. M for median. Oops, I lied. This is Q3. And this one is Q1. And then over here we have our max. Q1, the first quartile, marks the place where the first quarter of data ends. So 25% of the data is at or below this point. So 25% of the data lives in this range right here. Another 25% lives in this range right there. So this gives me an idea about how the data is spread out, a little different than the visual that comes from histogram. This last stretch right there is 25%. So I can see the middle 25% of countries' death rates are packed pretty tightly from 6 to 9, roughly. And then there's the largest spread. The upper 25% are spread out between about 9 and 16. So again, tells me additional information about the distribution of data, the spread of the data. Based on this, we can make another statistic, the width of the box. The width of the box is known as the interquartile range. And and it's abbreviated IQR, interquartile range. And the width of the box is simply Q3 minus Q1. So let's get that number out of the spreadsheet. So we'll make a new statistic down here for the interquartile range, IQR, and it's just equal to Q3 minus Q1. It's the width of the box in the box plot, 3.55. So the IQR in this case is equal to 3.55. And then what we can do is we're going to use that interquartile range by taking that width right there, and we're going to expand it by 50% and then tack that on to the end of Q3. Do the same thing on the other side. We'll take this width right here, expand it by 50%, and then tack it on to Q1 right there. So we're going to make these new boundaries, kind of like we use the standard deviation to make these boundaries above right here. We're going to use the interquartile range and the Q1 and Q3 to set up some other boundaries. So the boundary on the left that we're going to build is going to be Q1 minus 1.5 times the IQR. And on the right here, we're extending from Q3, so we're going to set up a new boundary on the right here. That's going to be Q3 plus 1.5 times the IQR. And this is going to give us another measure to look for outliers. So in addition to that 95% rule. So let's go over to the spreadsheet to do that. So the lower one, Q1 minus 1.5 times the IQR. Calculate it. We just equals, click on Q1. Subtract 1.5, the asterisk is multiplication in a spreadsheet, and then times the IQR. So I get a lower fence of 0.475. So if any country has a death rate below that, then they're unusually low compared to the rest. Lowest one I have here is 1.6, right? That's the min. So there's no unusually low death rates in this group. Upper one, Q3 plus 1.5 times the IQR. So always a good idea to put a label to indicate what you're doing. When you go back and look at it, you'll wonder what the numbers are otherwise. So starting at Q3, this time we look to the right, plus 1.5 times the value of the IQR here. So this says if a country has a death rate higher than 14.675, then that's unusually high compared to the rest of the countries. So it looks like, according to the histogram, there are some countries like that. So I have no unusually low ones based on this measure of unusual, but I do have some unusually high ones. So let's look at the bottom of the list and see who is greater than 14.675. And I have this Latvia, Serbia, Bulgaria. Okay, so higher death rates than the rest. All of these came from the 95% rule, and the box plot rule gives us further verification that at least these three are definitely unusual compared to the rest. These are kind of on the edge. These are definitely out there. So let's go back, put that in our drawing. So the marks calculated. So this is the min 1.6. So further over this way is that Q1 minus 1.5 times the IQR, and that was 0.475. And then out this way, somewhere over here, we just made another mark, and that one was 14.675. So those are boundaries that say, hey, inside here is usual, outside, those are outliers. They're a little weird compared to the rest of the data. So it gives us this new measure, so then I can talk about that in my description of the distribution. So other things I might add to my description here is that, let's say, that narrower middle part, right? Notice the second and third quarters. And again, we want to differentiate between a quarter and a quartile. Colorize for a sec. This range of numbers in here, that's the second quarter. It picks up after Q1, quartile 1. So a quartile makes a mark to differentiate the first quarter, which is this whole group right here. And then the second quarter picks up, that's right here. So a quarter is a group of data. A quartile is a particular measurement that marks where the next quartile starts and the previous quartile ends. Important distinction between a quartile and a quarter. One's a number, one's a range. So the, oops, color. The middle 50% of countries right, so I'm talking about the box. Have death rates between, let's see, 5.8 and 9.35. Now, since I'm actually mentioning numbers in the data set, I should mention what they mean. 5.8 what? 9.35 what? Deaths per 1,000 people. That's what we have here in the data. We're going to know what our data is talking about. And then we could also say 3 countries have unusually high death rates based on the IQR rule. Okay, so up next, we'll look at how to digitally put a box plot with a histogram.